Welcome to The Explainer. Okay, today we are unraveling a genuinely high-stakes mystery that is unfolding right now, literally as we speak, in the enterprise security world. Over the last few months, a massive, flashing warning light has just gone off across the tech sector, and it all revolves around one specific, kind of terrifying question. Why are investors suddenly panicking over the credentials we're handing to our AI agents? So today, we're going to unpack these massive market signals, look at some pretty devastating supply chain outbreaks, and, most importantly, dig into the core architectural flaw sitting right at the center of it all.
All right, let's dive right into this, because this number is where our story truly begins. $270 million. You know, this isn't some long-term industry forecast or a theoretical market cap. No, this is the staggering amount of capital that was actually deployed across 3 separate term sheets by 3 totally separate groups of investors in just 5 days. And what's really wild to me is that all of this money is aimed at solving one incredibly narrow but incredibly urgent problem: the security of AI agents operating inside enterprise systems.
Just look at the sheer velocity of this market signal. It's crazy. On day 1, Zenity closes a $125 million Series C. Right behind them on day 2, Obsidian Security raises $85 million, hitting unicorn status. And then by day 5, Oligo Security locks down a $60 million round. When 3 separate venture firms independently back the exact same hyper-specific thesis in a 5-day window, that is not a coincidence. That is a massive market signal. It's basically telling us that enterprise buyers are terrified. The market has officially stopped treating AI agent security as just some bolted-on feature for existing tools. No, it's become a standalone budget line. And why? Because the credentials these agents hold are quickly turning into a massive, massive liability.
So let's look at Section 1, when master keys leak, the massive scale of standing access exposures.
To really understand why the market is throwing $250 million at this problem in a single week, we have to look at the blast radius of these vulnerabilities. Because when these master keys leak, the scale of the damage is genuinely hard to wrap your head around. It's like a cascading supply chain disaster, all caused by unrevoked standing credentials. Take the LiteLLM incident, for example. A single unrevoked token in a security scanner let an attacker push malicious code that eventually exposed credentials across more than 434,000 pipelines, and get this, they did it in roughly 40 minutes. Then there's ChainDrop. This was an NPM worm, basically a self-spreading malicious package that specifically hunted for AI credential stores, threatening an entire ecosystem with 2 billion downloads. 2 billion! And with workflow automation platforms like N8N, a leaked API token isn't just a read risk. It essentially hands the attacker a direct path to do whatever that AI workflow is authorized to do, all across your databases and cloud platforms.
I absolutely love this quote from Shane Barney, the CISO at Keeper Security, because he just hits the nail on the head here. He says, every entry point traces back to a failure of credential governance. Secrets stored where they should not be, default credentials left unchanged. The absolutely crucial takeaway here is that these breaches, they aren't some highly sophisticated sci-fi movie-level exploits. Not at all. They are systemic failures. It all boils down to unscoped, standing credentials just sitting out there, waiting to be found.
Moving on to Section 2, human hacks and poisoned logs. Different entry points, identical root cause.
Now, what's really interesting here is comparing these 2 distinct attacks. Over on the human psychology side, we have a threat actor known as UNC6671. They use vishing, voice phishing, literally just calling up employees, pretending to be IT support, and capturing their live session tokens. They've extorted over $10.69 million doing this. No crazy software exploit, literally just a phone call. But then look at the other side. We have Ghostjacking, which targets AI logic. Here, an attacker sneaks a malicious instruction into a standard web application firewall lock. When a developer asks their AI coding assistant to review that log, the AI reads the attacker's payload, executes it, and gets completely hijacked. The hackers are essentially tricking the AI into doing the heavy lifting for them. But here's the kicker. In both cases, the attackers aren't breaking through technical perimeters. They are just hijacking existing legitimate access.
And boom, that brings us to the real aha realization. The entry mechanism is totally different, right? Tricking an employee on the phone versus poisoning a log that gets read by an AI agent. But the exploitation of standing access, it is exactly the same. Whether it's a human session or an AI agent's API key, once the attacker inherits that access, the resulting damage relies entirely on the fact that those standing credentials are broad, persistent, and unscoped.
Which brings us nicely to Section 3. Authenticated is not authorized. This is the big conceptual pivot.
Okay, let me explain this critical distinctions because it literally explains this entire systemic failure. Authenticated is not authorized. Proving your identity, authentication, does not continuously guarantee that a specific instruction you give is actually permitted, which is authorization. For instance, take the chat-made vulnerability they found in Microsoft Copilot. An attacker hides an instruction inside a document. When Copilot reads that document, the attacker inherits a genuine authenticated session. They didn't even steal a password. They just hijacked the prompts while Copilot just happily keeps operating under the victim's perfectly legitimate identity. And let's look at how our standard human-in-the-loop controls completely fail because of this exact flaw. With Chatmate, like we just talked about, the attacker inherits the session through a document. With Ghost Approval, an AI assistant shows a developer what looks like a totally harmless file path in an approval dialog, but it's secretly writing to a sensitive target using a symlink, which is basically a deceptive shortcut file. Or with Fake Agent, where malware is served directly from a totally legitimate AI provider's domain. In every single one of these cases, the identity layer sees absolutely nothing anomalous. It trusts the identity, but it totally fails to verify the origin or the true target of the actual instruction being executed.
So, I want you to ask yourself this. Really think about it. Why on earth does the system trust the payload just because it happens to trust the identity? Let that sink in for a second. This is the urgent problem we are facing. We don't just need better detection tools so we can sit back and watch the disaster unfold in real time. We need a structural, foundational solution.
Let's get into the fix. Section 4, the design layer solution, removing the master keys from the room.
So how do we actually address this upstream way before detection tools even enter the chat? We use something called alias indirection, and this brilliantly illustrates how we do it. Step 1, you completely remove the real full-scope keys from the agent's execution context. Step 2, you issue a scoped alias that is tied only to that one specific task. Step 3, you resolve that alias back to the real access only at the authorized execution boundary. Essentially, you're taking away a super dangerous permanent master key and you're swapping it out for a highly restricted temporary key card that only opens one specific door for one specific task.
Because if you set your architecture up this way, you get sub-2-second automated revocation and cryptographically verifiable per-action proof. And guys, this is exactly what legal teams and insurance companies are desperately demanding right now. Believe it or not, insurers like W.R. Berkley are actively writing absolute exclusions for directors and officers' liability coverage when it comes to AI decisions. Why? Because they literally can't model the risk of an over-credentialed agent going rogue. But by using a design layer that enforces verifiable per-action proof, you create the exact audit trail you need to prove, beyond a shadow of a doubt, that an agent only did what it was strictly authorized to do.
So I'll leave you with this pretty provocative thought. Are your AI agents holding master keys to your enterprise right now, really? If a bad actor hijacked your agent session today, what exactly could they reach? I think it is officially time to audit your identity architecture, completely rethink your trust boundaries, and finally remove those master keys from the room. Thank you so much for joining me on this explainer, and we will definitely catch you next time.